We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
Nothing as beautiful as Chandra sailing off on its way to work.
Long before astronomers found evidence that black holes existed, these exotic objects have captured imaginations. In the 21st century, scientists not only have proof that black holes are real, they continue to make startling discoveries, both about individual black holes nearby and about their populations across the universe. Dr. Paul Green of the Chandra X-ray Center explains what black holes are.
A black hole is created whenever matter collapses onto itself so densely that anything that comes too close, even light, cannot escape it. What defines a black hole is that its gravitational pull is so large that at a close enough distance, even the fastest thing in the universe, which is light, cannot escape. There's a term for that distance. It's called the event horizon. No event that occurs closer to the black hole than the event horizon can ever be seen by an outside observer like us.
If all the material that passes over the event horizon is lost forever, how do astronomers ever see a black hole?
We can never see a black hole itself because light cannot escape it. But we can detect light emitted from just outside the event horizon. When material like gas and dust falls in towards a black hole, because there's always some amount of spin to the material, it swirls into an orbiting whirlpool-like structure called an accretion disk. The orbital speeds are different at different places in this disk, causing friction to heat up the gas. Near to the black hole, temperatures are beyond red hot or even white hot. The gas becomes X-ray hot and gives off profuse amounts of X-ray light. Such high temperatures are very rare in the universe, so X-ray telescopes are an excellent way to find and study black holes.
Black holes are rather similar to one another, except when it comes to size and mass. How does the universe end up with black holes in different sizes and masses? It turns out it all depends on how and where the black hole is born.
There are at least two types of black holes for which we've seen many examples: stellar black holes and supermassive black holes. Stellar black holes are created when a single very massive star dies. A star more than about 3 times as massive as the Sun lives only a short time before it explodes as a supernova, and its core collapses into itself to become a black hole. These stellar black holes range in size from about 2 to 15 times the mass of the Sun, and can be found scattered throughout a galaxy like the Milky Way. Supermassive black holes, on the other hand, may be from 1 million to 1 billion times more massive. These are found only in the cores of galaxies. When they're active, supermassive black holes also give off copious X-rays and are known as quasars. But the nature and origin of supermassive black holes is much less clear than for their smaller stellar cousins.
While astronomers have known for many years that black holes come in these two very distinct small and large categories, there has always been a question of whether there is an in-between variety. This quest for a so-called intermediate mass black hole took an interesting twist when astronomers using Chandra found an intriguing object in the galaxy known as M82. While not conclusive, this object suggests that maybe black holes do in fact come in this medium size.
One hypothesis that astronomers have put forth for the formation of supermassive black holes is that they begin simply as an accumulation of smaller stellar black holes. This requires a very dense cluster of stars, but it also requires that as pairs of black holes go into close orbits around each other in these clusters, they must lose orbital energy somehow. If a bright star could be found orbiting such an object, astronomers could directly measure its mass. Proof of the existence of these intermediate mass black holes would help to complete the evolutionary chain between stellar and supermassive black holes, between stars and quasars.
We've just begun to explore the intriguing topic of black holes that are so fantastic that they seem to belong in the realm of science fiction. In fact, they are firmly rooted in the reality of physics. scientists can use tools such as Chandra to test their theories and ideas about black holes, and as they do, they continue to be amazed by these mind-boggling objects. For more information about the Chandra X-ray Observatory, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.